Relation and function. We're going to illustrate relation and function, verifying if a relation is a function. What do you mean by relation? So we have relation is a set of ordered pairs. So relations we have that is setting of ordered pairs means we have the x and y. So x is the domain. So another call for domain is input, and the domain or input is the relation is the first set of the coordinates. So it means that is x. And we have the range that is output is a set of the second coordinates, or we can say that is y. Relation is a function if the domain has one element correspond to one or many elements of range. So it means the domain not be more than two or many. It must be one element. We can say not functions if two or many elements of domain corresponds to one or many elements of range. Illustrating relation and functions. We have different types of relations, one-to-one, one-to-many, many-to-one, many-to-many. So we're going to identify which of these are the functions or not functions. So these are the correspondence or the diagram. The one-to-one is considered as functions. Why? Because we have one element of domain corresponds to one element of range. And many-to-one is function because we have one element of domain, even though we have a corresponds of two or more elements of range. And one-to-many is not function because we have two elements of domain used to corresponds to the range. Many-to-many also is not function because if you consider, as you can see, this one, the domain used a lot to correspond to the range. Vertical line test. A graphical presentation of a function if and only if no vertical line intersects the graph in more than one point. Again, we use the vertical line test to identify if these functions are not functions. So let's have the ordered pairs 2, 1, 3, 2, 4, 3, 5, 4. As you can see, we're going to plot the 2 and 1. This is a 2 and 1. That's for letter A. And for letter B, that's 3 and 2. For letter C is 4 and 3. And 5 and 4 is that's for letter D. We're going to use the vertical line test. And this is the vertical line test, the purple one. So as you can see, there's no intersections. There's only one points here. So it means that is pass for function. Let's have the V and C and V. So it means if that case, the graph is like that, if we go into test our vertical line test, so it means that is a functions. In vertical line test, we need only one point, not more than one point. There are many real-life world situations where the value of one variable depends on the value of another variable. One situation is shown below. Oliver's supermarket holds a closing out sale. All merchandises are sold at 10% discount. For the convenience of shoppers, the marketing supervisor considers a table of market prices as X and their corresponding selling price as Y. We're going to make a table. The market price is the X and the selling price is Y. So the market price is 50, 100, 150, and 200. And the selling price for 50 is 45, for 100 is 90, 150 to 135, 200 to 180. And the given is a relation can be represented by the set of ordered pairs, marks, price, and selling price. So we have to make an ordered pairs 50, 45, 190, 150, 135, 200, and 180. Shows that there is exactly one value of y that corresponds to every value of x. In mathematics, we say that y is a function of x. We can also use diagram to describe correspondence and function. We have the domain and we have the range. So let's have the circle first and another one. And this is 50 pesos corresponds to 45 pesos. And 100 pesos correspond to 90 pesos. And 150 corresponds to 135. And 200 corresponds to 180. So it means we have the activity. Determine whether the following relation are functions or not. So we have the number 4 and 5. Let's have the number 1. 1 and 5, 2, 6, 3, 7. So we're going to observe. So the domain here is 1, 2, and 3. So as you can see, there's no repetitions of 1, there's the repetition of 2, and also the 3. So it means that is function. Number 2, 1, 2, 2, 4, 2, 5. Observe the domain, the 1, 2, and 2. So as you can see, there's repetitions of 2 here. The number 2, so it means does not function. And number 3, 1, 8, 2, 9, 3, 10. So as you can see, there is no repetitions of domain, the 1, 2, and 3. So it means that it's function. Let's have the input. The input is considered as domain. The output is range. The input is 1, 2, and 3. There's no repetitions of the domain, so therefore that is functions. For number 5, there's no repetition again for the domain, so that is function. Example, use the vertical line to identify graph represent a function. Let's have the number 1 and the number 2. Let's go first for the number 1. As you can see, there's only one point when you use the vertical line test. So that means that it's function. And this for number 2, we're going to use the vertical line test here. There's 2 points here. The points of this above and the point here below. So it means does not function. And activity, identify if the given graphs of functions or not. For number 1 and for number 2. For number 1, so as you can see, there's one line here. We did not use the vertical line test, but if you're going to check it out, the vertical line test, there's a lot of points lies here in the straight line. So it means that's not functions. And the number 2 also does not function because we're going to use the vertical line test. So there's 2 points here lies in this graph. Not function. Let's start the given for number 3 and 4 and 5. So let's go first for number 3. If we're going to use the vertical line test here, so it means that is functions. So there's only one point here. Then for number 4, we're going to use the vertical line test here. Is only one point lies on there. So it means that is function. Let's have the number 5. So we're going to use the vertical line test here. There's 2 points lies on there. So it means does not function.